Perfect. I hope you all had a great event so far. I'm enjoying it, and it's a wonderful one. So let's keep doing that, right? All right. So first thing first, I need to tell who am I. I'm Seyed Jafari. I'm a senior software engineer at Revolut, and you can pretty much find me on any social media using that handle on the bottom of the slide, or just head to my blog. Before we begin, I would like to express my sincere condolences on the occasion of Imam Hussein Arbain. With that said, I would like to talk about first thing first, what is a flow? Everyone is talking about it these days. It's very hot, but it can be problematic to actually get to know it. So by the definition of the dogs, I forgot something. I have to go a little bit fast paced in order to cover everything that I've planned for. So please excuse a little bit of the speed that might be too fast. All right. So the doc says that it's an asynchronous data stream that sequentially emits values and completes normally or with an exception. For me, that's a little bit too much to understand at first glance. But the way that I visualize it for myself is that flow is a pipe that you put events from one side of the pipe and then you receive it from the other side of the pipe. What you can do multiple things in this pipe from the beginning to the very end, and you can also modify the events flowing. But keep in mind, you cannot pick a single event or particular event from the pipe. So everything is a stream. The events are flowing in the stream. You are going to receive in a stream, not events. So just keep in mind, it's just about the streams, not the events. And this picture used to be applying to reactive streams. Since flow is very close to them, I think it applies to flow as well nicely. With that said, let's see how we can actually create flows in our code base, and how does it look like, just a quick glance, and then what should we expect. So in a very simplest form, you can create a flow using a flow of function, or it's called builder function, as we can see it later down the talk. And it returns a flow of the type of the events that you're returning. In this case, it's events of a string. And or in my words, it will create a pipe that will emit string events. And then we can collect that pipe using a collect function, which accepts a lambda, and then lambda will provide the events that is flowing into the pipe for you. Flows are very nice. To explain how they actually work under the hood, they're basically on top of Kotlin coroutines. Kotlin coroutines are one of the greatest features of Kotlin language, and I think everyone that uses Kotlin language is kind of either loves the coroutines or actually using them just for the fun of it. So, but in a nutshell, to have everyone in the same page, Kotlin coroutines in a nutshell is that if you want to run a function in a different coroutine or in different context, you can just prefix it with suspend keyword, and then you need to run this function, which is a special function right now in a coroutine. And to create a coroutine, you need a coroutine scope, which manages the coroutines. So if you have a scope, you can just call coroutine builder function launch, and then inside the body of the launch, you can just call your suspend function. Since Flow is built on top of the Kotlin coroutines, it inherits pretty much all of the power and the functionality of the Kotlin coroutines as well. Excuse me. With all those definitions out of the way, let's look into what are the flow functions, or in other words, operator types. So on flows or reactive streams, we don't really refer to functions as functions. People like to call them as operators, but I try to use them interchangeably. But don't freak out if you hear operator instead of functions. They're basically the same thing. The first type of functions or operators is builders or creators, which will actually create the flow for you. The next one is intermediate, the last but not least is the terminal. Now let's dive into the first type, which is the builder and creators. There are a number of builders and creators in Flow that you can utilize to create your flow in the way that is suitable for the situation. So the easiest one that we saw is the flow of, which will just emit the values that pass to the function arguments. The next one is the empty flow. So this is just creates a flow and then immediately completes it without emitting any event. The next one is the flow. This is just a pure flow. If you want to have the full power of modifying or creating or customizing the flow, this is the function for you. You can use that. The next one is callback flow and channel flow. These two are very important, especially if you're going from a callback to callback land to the flow land. These will come in handy. We'll look at them a little bit deeper in the next slides. And then we have list of items as flow as an extension function, as well as a list of flows that we can use .merge to actually merge all of the flows for us and create a single flow that we can singularly subscribe to it or collect from it. Going back to the channel and callback flow, they are basically the same thing, bottom line, but callback flow is a little bit safer because it forces you to make sure that you call await close on the bottom of the Lambda function. The reason that is safe, because if you don't call await close in a channel flow or callback flow, is that it will actually immediately finish the flow block, and then the flow will be completed without actually emitting or keep listening for the callbacks that you have created. So in order to keep it open, you should use await close, and the callback flow will actually forces you to use that. But under the hood, both of them are using channels. Channels, they're a very big topic for themselves. They require, I think, a separate talk to just cover, but they're also powerful, and you can use almost all of the powers in this callback. All right, so the next one, and now that we have builders covered, let's go to the intermediates. These are the most used operators, because with creators and terminals, you just use them once, but with intermediates, you usually use them a lot, and also in frequent orders. As you can see, there are a lot of them out there already built, but you can feel free to create actually more of them based on what you need. I usually find these quite enough for the use cases, but I have created once or twice custom operators that I needed to. But let's dive into them and see what are they and what they do. Just keep in mind that the ordering that I'm presenting here is just purely my taste, and it is not listed anywhere. So the first one is flow.filter. What it basically does, the name actually suggests or gives away the operation, is that it filters away the events that you don't like to coming down the downstream. And the next one is map. It converts basically your events from upstream to another type of the event to the downstream. So in this case, I'm converting from integer to strings. The third one is with index. I don't really happen to use this one a lot, but it just converts all of the events to pair of the index of the event and the value of the event. It can be useful, but I don't see much often. And then drop. Let's go to the next one as well, and then take. So the reason I'm going to explain these two together is that it's important to remember that these apply to the first events, not the last one. So it drops the first event, in this case 1, and then take also takes the first event, in this case again 1, not the last ones, not the middle ones. Just keep in mind. So if you want to drop the couple of first, a few first events, just use drop and the number, and take also the same. Flow of the distinct until change. This is one of the most powerful operators that exist on Flow, which allows you to just make sure the events that you're receiving is actually distinct from the previous one. So this is very useful, especially if you are like presenting a state or publishing a state regularly to some sort of a UI in terms of Android. Then it prevents your screen from flickering, because just you're re-rendering the same thing on the screen. So if the two objects are the same, it just skips and then keeps the last one. All right. So the next one is buffer. What buffer does is that it actually splits, for now, just ignore the on edge, we'll cover it later. The buffer is a way to split the upstream and a downstream. The way I mean split is that the upstream will run on a separate coroutine than what we are collecting in a downstream. Why is it useful? It's useful because if you're collecting too slow, in this case, I'm delaying I'm delaying in 1 second for each collection, and your upstream is actually faster than your collection, or basically the downstream, then you will be wasting time just by waiting the collection to happen, because other operators, in this case, each can do their job while collect this processing is still like 2 or 3 events before. So buffer allows us, provides us with that. In this case, you can see that since the collect is very slow, the on each goes ahead and prints all the events are in the flow, and then collect goes and prints out each event, I think in 3 seconds. Without buffer, the whole thing on each and collect will take 3 seconds, not just the collect. All right, so the next one is debounce. I like debounce a lot because I keep using it with the UI elements, especially the click listeners. So what it does is that it skips the events that are happening in the shorter time frame that you specify. So in this case, I'm specifying 100 milliseconds, and you can see that I'm emitting events of 1, and then delay of 50 milliseconds, which is not enough for our window, and then emitting events of 2. So what debounce does is that since the window or the delay is not enough, it will skip the first event and just keep the second one. And then the window is passed, so it just emits the 2 to the downstream, and then we'll check for the next event. So it's very useful because if the user is keep clicking on a button and you just want to take the last click that the user has made during the, let's say, 1 second period, you can just use debounce as a handy tool over there. But just keep in mind that debounce will actually drop the first element, not the last one. So if you want to keep the first element, let's say you want the first click to be taken, but the rest of them in that time window to be dropped, then you need something called throttle first. That doesn't exist in the Coroutine library, but you can find code on GitHub or in the issues of the Kotlin coroutines. The second part. So now we are into the on start. So what on start does is that you have a pipe already set up with a lot of events coming on, but you want to make sure before any of the other events, this particular event goes the first. So that's the way it does it. And you can see that it goes, the first one, the on start event goes before the upstream. So the on start on the very bottom takes precedence than the one that on top, and then the entire flow events. So it's 5, and then 4, and then 1, 2, 3. So, and just keep in mind, if you have 2 on starts right next to each other, the bottom one will be the first one. And then the next, and then the next one, which we already used this, is on each. On each is very equivalent to do on next if you're coming from RxJava land, except that do on next is very limited in terms of what it can actually achieve or what it can affect, how it can affect the pipe itself. On each, on the other hand, it has control over the pipe as well. So first of all, the callback is a suspend function. So you can call other suspend function in suspend, and I'm sorry, in on each. And if you delay the if you apply some delay, in this case, delaying 1000 millisecond or basically a second, on each, the whole pipe will actually be delayed. So it's actually good, but you have to be very careful not to mess up the whole pipe. And we already saw filter, but then we have on empty. So just remember that all of the things that we are talking about is just cold flows, and we haven't touched on hot flows. And all of these are built on top of cold flows. We'll talk about hot and cold later down the talk. So now back to on empty. If we have a empty flow or pipeline, remember we could also use empty flow to create an empty flow. If we needed like a callback to be fired in case our flow is empty, then on empty will come in handy. You can actually create a whole new flow just in case if the upstream flow is empty. So that is quite handy. And then the next one is on-completion. So this one is useful if you want to see how the flow is finished, or you want to emit some more values right after the upstream flow is completed. And the way you can actually recognize this is just check if the throwable returned to you is null or not. If it's null, then the flow was gracefully finished or normally finished. Otherwise, something went wrong and an exception was thrown, which can be catched here. Just remember, if the exception has happened, you cannot emit any more events. I'm not sure if it actually throws another exception or not, but I know that you cannot actually emit anymore. One more very important gotcha about this on completion is that it is not the best place to do cleanups or resource cleaning. So if let's say if you have a socket open and you want to close that socket whenever the flow is finished, it is not the best place. You should do all of that in, let's say, in your flow creators. So use those operators or functions to clean up your resources, not in on completion. The next one is catch and retry when. So a retry when is useful. Let's say we have a request that we are firing to the backend API, and then this request fails for some network weird issues. If you want to just repeat that request without changing anything, we can just call retry when, and it provides us the attempts, the number of times that we actually tried already, or and the cause of the problem. So we can actually check, was it an authentication error, or was it an IO exception or something like that? So to act accordingly. So it does come in handy when dealing with exception that can be recoverable. The catch, on the other hand, is that something went wrong and we didn't do anything about it. It came all the way down to catch. Catch will receive the throwable or the exception and will allow you to actually emit more items downstream. Just remember, there is a catch with the catch, that it only receives the exceptions on the upstream, not the downstream. So it doesn't know what's going on the bottom side of it. It's just on the top. Part 3 of the intermediates is the flow on. So far, all we have been talking about is just running the flow on the same coroutine that we are launching. But it's not always the case. So we can actually switch our context from the collection context to anything that I like, anything that we like. Just keep in mind again that flow on also operates on the upstream, not the downstream, and goes all the way up to the until the previous flow on. So in this case, a flow off will be run on the default dispatchers or context, but then on each will be on IO dispatcher or context. And this IO will not go beyond this the top default flow on. All right, that was a quick part. Let's go to the force. This one is about transform. So I can say transform is the most powerful operator that Flow has. And even if you go and see the other operators like map, filter, you will see that they have been implemented using transform. The best part is that transform is nothing fancy. If you look at the implementation of transform, you will see that it's just a pure new flow created for you with the Lambda pass as the block to do the operation. The best part, the cool thing about transform is that you can mix multiple things. So in this case, I'm filtering the events, also firing a request to some API whenever I see the event is fit my case, and then I'll emit the results of the API request to the downstream flow. From time to time, I like to see transform as a way as a bridge from the functional world to the old imperative world. So if you want to call a couple of functions to that actually affects your pipe, maybe this is the go-to. All right, the next one is zip. With zip, you can combine. You can actually zip two flows together. The reason I'm not using combine because there is actually a combined flow operator as well. So the difference between them is that for zip, in order for zip to work, all of the flows have to emit the same number of events in order for your callback to be called. So if the first flow, let's say, triggers 3 events, but the second flow only triggers 2 events, the last event from the first flow will be waiting until the second flow emits another one. Just keep that in mind. On the other hand, combine will take whatever exists from the other flow and then will provide the callback for you. So I like to use combine a lot myself when there is one flow that emits only one value, but I want to combine it with another flow that constantly emits more events for me. So let's say a user, I have an API that's called to fetch the book list. This API just returns single time all the books that I have on the backend server. So there's only one event and I'll receive it and then it's done. With combine, I can listen to the user, type in the query for me, and the moment that the query is changed, combine will give me the last book list that I have received, and then the new query, I can filter the books and then return the filtered books to the user again. All right, so we have flat map operators. There's actually 3 different variations of flat maps. But before we actually see them, what is the flat map? So flat map allows you to take an event, and then for that event, return a new flow, or basically a new pipe. This comes in handy in different ways, but we'll see them in just a bit. So the first one is flat map merge, which will actually merge all of the events emitted by the child flows that you have created with no orders. And then we have flat map concat and flat map latest. This is actually interviewers' favorite questions. So if you want to do an interview, make sure to read up on the difference of the flat maps. They love it. I don't know why. So the first one is flat map merge. As I said, the order is not important. So all of the child flows will run in parallel to each other. As you can see that A1, A2, A3 will be emitted immediately, but then the order is unknown for us because it could be B1 or B2 at any order given to us. It is very good if you want to use a maximum parallelism in the flows. The next one was flat map concat. This one, on the other hand, keeps the order and thus will actually might be slower than the flat map merge because it cannot run in the same parallelism as the flat map merge because the order is important. So you can see that A1 and then B1 goes ahead and then the next one is A2 and the B2. The order will be preserved. The last, again, that the one that I happen to be using quite a lot is flat map latest. The reason that is very useful is that if a new event comes from the upstream flow, it cancels the previous child event that it created for the previous event and creates a new one. So to give an example, let's say you have a search box in your Android app and you want the user to quickly search for new items. And for each search query, you will fire a backend request. You don't want all of these backend requests to come back sequentially. Rather, you want to keep the last result from the last request that the user has written the query for. So flat map latest does help quite a lot in that context. All right. Oh yeah. So forgot about this one. I have an example query for the local database. As I've just explained it just cancels the previous observing of the database. So if you're observing your database, but based on a query that the user has typed, you can just cancel the previous observation and then create a new flow for that query. Part 5. And then we have reduces. So reduces are a fancy name of how we can accumulate data and the events that have been published in the in our pipeline. They're especially useful if you want to create, let's say, a finite state machine, or in MVI architectures, we can use them quite a lot. So there are two intermediate operators for reduces: running reduce, and the other one is a scan. We'll look at them real quick. Running reduce allows you to just reduce on the events of the flow that is emitting. So the first event, which is 1, will just immediately goes through, but the second one will have, and then 1 will be cached as the accumulator. For the next event, the value will be 2, accumulator will be 1. So there will be time together, and 2 will be published. For the third one, the 2 will be the accumulator and the value will be 3. That's how the running reduce works. Very much similar. A scan is the same thing, except that it will accept an outside variable as the first event. So you can just pass the initial state and then it will immediately publish that initial state. But from there on, for any event that is published from result flow, it will get calculated based on the last state that you created. So again, it is a very suitable operator for MVI and finite state machines. Right now, we are down to terminals. So terminals are the operators that actually finish or start listening to the events that the flow is emitting for us. Again, there are a number of them. We can really quickly have a look and see each one in details. So collect is the first and foremost. It basically just collect the events as they go through the pipe and they reach the end. And then we have collect index, which is the combination of collect and with index operator. Nice and handy. Launch in, so very much like collect. If you don't care about flow events that are happening and you just want to start the flow so that the flow starts, you can just pass launch in and then scope to it. Yeah. The next one is collections. So there are a couple of there are a few operators, terminal operators that allows us to convert our flow to a collection. Just keep in mind they only work with code flows. Again, more on code flows and hot flows later. So the first one is toList. So basically, it converts our flow events to a list of those events. The next one is set, converts it to set. And then the first is, so this is my name, so it's not written anywhere. I assigned them myself. Single is the first one. What it does is actually takes the first event and makes sure that there is no other event on the flow. If there is, then it will actually crash or basically throws an illegal state exception. So if you want to go very aggressive with your flow events, use single. Otherwise, you can use first, which will take the first event and then will not care about the rest of them and will finish the collection. So keep in mind. Reduces, again, as I said, we have reduces in the intermediate and also in the terminals as well. So the first one, again, is reduce. But there is a subtle difference between reduces in the terminal and intermediate. In the terminals, they will only return a single value because the function can only return a single value. So in here, the reduce will create accumulator as it goes on until the flow events are done, and then it will return the final result from all of the events, in this case, 6. Again, we have the similar, we have another similar to scan, which is fold. Fold accepts a variable from the outside world, from the outside of our pipe. So it can be useful. But remember, again, I'm just emphasizing, it will only return a single value. All right, so I've been talking about cold and hot quite a few times during this talk, but what are they exactly, and what are we even talking about? It was hard for me at first to grasp, even in our Java land. So what is the hot? What is the cold flow? After all, not everyone likes to talk about weather in terms of technology. So again, another example came up. So I thought maybe I should explain it using an example. Let's say that the cold is rowing and the hot is a car engine. The way it works is that as long as you're rowing, your boat will keep moving forward or backward. But the moment you stop rowing, the boat will stop as well. On the other hand, a car engine, forgetting about ignition and start and end, the car engine will run as long as it's on, as long as it exists. And it doesn't care if you've engaged your gear or not. It will just keep running, no matter what. So a cold flow looks very similar to rowing. So it will only start working when you collect it. But a hot flow is like a car engine. It will just immediately start working whether or not you're actually collecting from it. They're both useful. They have their own use cases. But so far, what we have been talking about is just cold flows. And from now on, we'll be moving on to the hot flows. I hope with this example, it makes more sense. It did for me. So hopefully for you guys too. And then, so now entering the hot flows, be careful from now on, everything will be hot, including your computer. So don't touch anywhere. The first type is SharedFlow, or the mutable version, mutable SharedFlow. And the second one is StateFlow. Let's see what they are exactly. So mutable SharedFlow, as I said, is a hot flow. You can create it using the function, and you can emit values from outside of the body. As you can see, I'm not passing any callback, any lambda block to the creator function. I'm just creating it, and I can call .emit. I'll show it later. I can call easily .emit on the SharedFlow and then emit more values into the flow. The second way to create the SharedFlow is if you have a normal code flow, but you want to share the events with multiple receivers, then you can just use dot sharing and then pass this scope. One of the use cases is that, let's say you have a single socket open, but you want to use that socket events in multiple places. Sharing can be a good example of a good fit in for that situation. Just keep in mind that this parameter that I'm passing called eagerly, it controls how the shared flow starts the working. Remember that car engine I told you about? So the car needs to be, the car keys needs to be turned in order the car engine to be working, right? So same semantics here. The shared flow can be configured to start working with the first collection or eagerly without any collection, just to start working immediately. And then the emitter will be, we can use the SharedFlow.emit, which is the suspend function, or try emit, which is the normal function. Very similarly, state flows can be created exactly the same way with their function creator functions. Oh, sorry. And then they are actually built on top of shared flows. The difference is that they will cache the last event for the new collector. So if there's a new collector listening to the state flow, it will just immediately pass the previous value that is cached in the state flow, and then will publish any new event that comes in. Since there's only one value, you can actually use a dot value to publish new events to the downstream collectors. Again, since StateFlow and SharedFlow are built on top of Flow itself, all of the powers, all of the intermediate operators that I showed already apply to this hot flows as well. Just keep in mind, some of those terminal ones like toList and toSet will not work because SharedFlow does not stop, almost never. So very important. We shouldn't end the talk without talking about testing, right? So testing the flows are quite easy. If you have a cold flow, just immediately you can. For me, the easiest way to test it is just turn it to a list of events and then test that list normally the way you do the other lists. Simple as that. But when it comes to the hot flows, you cannot really turn it to a list because it doesn't finish, as I just said. So there, on the other hand, we have a library called Turbine. Thanks to all of the Score folks that for creating this library for us. After importing this library, you can just call .test on any flow, and then we'll cache all the events that has happened in the shared flow, and then you can call expect item to get each one of them sequentially. Or if you don't care about the rest of the flow, just call cancel and ignore remaining events, and then the run blocking will finish. That's pretty much it. If you want to see flows in action, please head on to this project that I have. It's called Rion. It's pretty extensive with all the flow usage, MVI architecture. Also, it's in multi-platform, so it might be a good place to see some of those harder operators in action. But if you forget about one of the operators, don't worry. The flowmarble.com is, I think, the best place to just quickly remind them, as it has beautiful marbles. That's it. I hope you enjoyed flowing into the flows. I definitely enjoy. Keep in mind that we are actively hiring in a wide range of positions. Head to our website for openings. Have fun.
Thank you so much for that wonderful talk. I know I learned a lot, and it was really great for kind of helping my mental model, like mapping from what I know about RX and learning about what operators do similar things with flows. So thank you for that. We have a couple minutes for Q&A. Remember, for everyone watching this talk, if you head to Slack and go to the Operation Flow channel, feel free to drop your questions in there. To kick us off, the first question we have is, when would you want to use take instead of first? I know first is terminal and take is not.
Yeah, so that's a good one. As she mentioned it, the first will actually end the flow, so there will be no more emissions. But will literally take those amount of events from the beginning of the flow. So let's say I open a socket, and then I'm only interested in the first 10 events of the flow. So I'll use take, and then I take the 10 elements. It will the first 10 goes below downstream, and then the upstream flow will be terminated. But with first, you will only get the very first element returned to you as a return type of the function. So there will be no more emissions, there will be no more events, and you cannot actually operate on it using the flow operators.
Gotcha. Thank you. Another question. How would on empty know that a flow is empty?
Oh, that's a good one. So on empty basically works based on the flow creator block. If if I can actually go back to the here so that everyone can see it quickly. Yeah, there we go. So as we saw here, as the moment that this block finishes or reaches to the very end, the flow is finished. Unless you're using callback flow and channel flow. That's why I said that await close is very important, because await close will keep the flow running as long as you're listening to some other callback. Whenever the flow calls the flow is finished or basically terminated or runs out of the block, then it will check, okay, was it empty or there was events passing through the flow? If it was empty, then that the callback will be get called.
Gotcha. And I think that gets into our next question, which is how do flows know that they're done? Is it that they're waiting for a close or a cancel?
I think I kind of answered that together with the previous question, but yeah, so that works. Just keep in mind, closing or canceling the hot flows are not easily possible. So if you really need the cancellation or closing after some resources, just fall back to the cold flows. That will be easy to manage.
Gotcha. Thank you. Next, what is the difference between reduce and fold?
All right. So I don't know if I can pull up the correct page again real quick. Maybe this one. Yeah, first of all, reduce and fold both are kind of the terminal here, but there are intermediate operators as well. So keep in mind that both of them are available. The only difference that is visible to me, at least, is that for reduce, it only operates on the events that are published by the original flow. So if you want to inject something from the outside world, you cannot use reduce, and the best option is going to be fold. And since fold and reduce in this context is used as a terminal operator, there will not be more events down the stream because there is no more stream. They will work until the flow is completed, and then they will return the final value to you. If you need to reduce or fold on the flow and then return another flow on the bottom side, just use the intermediate version, which I showed earlier. I hope I answered that question.
If you need more clarification, Lauren, feel free to reach out in Slack and you can continue discussing there. All right, let's move on to the next question. So Josh says, I have a lot of experience with RxJava currently, and while a lot of this feels very familiar, I'm curious if someone can point out anything that folks like myself should be aware of when switching to Flow from Rx. So if you have any tips there.
Yeah, so in general, if you're coming from RxJava to Coroutines, what I would suggest, it all looks very easy, and it is actually easy, but there's always a but in there. be careful about the exceptions because it just keeps hitting everyone. And if you're not too familiar with the exceptions, just ask a friend or just keep Googling. There is tons of content about exception handling in coroutines and flows. Since they're built on top of coroutines, they have the same, sometimes weird behaviors with exceptions. You don't have to grasp it all, don't worry. But I would suggest that maybe read up a little bit on the exception uh, topic on the coroutines.
That's a good tip. Um, comment, thanks for a great talk. It was very helpful. Will you be posting your slides?
Definitely coming up.
Awesome. Thank you. Very helpful. What are the benefits of migrating the existing Rx Java code to Flow?
That is like a religious question. So, I mean, there can be benefit and there can be downside, but I would say most of them would come from your team. So, or your code base. One of the most benefits that I've been using the flows for is their ability to be used on a multi-platform project. RxJava with itself is not possible to use it in different platforms, especially on iOS, but flows are on the other hand. So if you are interested in multi-platform or if you plan to sometime in future to go to multi-platform world, flows can be a good option, even though they're not fully like implement or 100% ready, but they are fully functional. So that's one point. The other one is that when using Flow, you'll get all the coroutines power for free. So something RxJavas are very functional in the way that you use them, but with coroutines and extension to the flow, you don't really have to be functional. You can be imperative. You can just call normal function, normal suspend function, and use them. So if you switch, I don't say that migrating, or if you continue to flow, then you can actually benefit from that. But if you have a code base, I'll give the RxJava benefit of that. If you have a code base that is already on RxJava and it's working fine, you don't really have any reasons to move away to flows because it just works. Personally, off the record, I like RxJava more than Flow in some cases, but I happen to be using Flow more often.
Gotcha. Thank you. We have 2 minutes till our next talk, so we'll close the video chat Q&A for now. There's still more discussion and questions in Slack, so feel free to continue discussing there. Thank you so much for sharing your talk with us.
Cool. I'm glad that I managed to share, and thank you for the opportunity.
Yes, absolutely.